Electrolysis is a method used to split apart ionic compounds into their elements using electricity. Electro means electricity, lysis means to split up.
The ionic compound is either melted or dissolved to form a solution, depending on the compound. This forms a liquid in which the ions are free to move. This is the electrolyte. Electrodes are added which are connected to a power supply. This forms a complete circuit so current can flow. The positive electrode is called the anode, and the negative electrode is called the cathode.
You can investigate the products made from the electrolysis of different ionic compounds using inert electrodes. Inert electrodes are ones that do not react in the electrolysis process. They are usually made from a form of carbon called graphite.
The first step is to put on eye protection and pour some solution into a beaker. Let's start with copper chloride solution. This is copper chloride dissolved in water, so will contain copper ions and chloride ions from the copper chloride, and hydrogen ions and hydroxide ions from the water.
Next, the electrodes are placed into the solution. It is important that the electrodes do not touch each other, as this will cause a short circuit and electrolysis will not take place. A good way of making sure that the electrodes do not touch is to place a lid with 2 holes in it on top of the beaker, and then put the electrodes through those holes.
The electrodes need to be connected up to the power supply. The power supply used should be a low-voltage power pack which is plugged into the mains. Leads with crocodile clips at one end are used. The leads are clipped onto the electrodes and then plugged into the DC, direct current, terminals of the power pack. These are red and black. The red terminal is positive and the black terminal is negative.
At this point, it is a good idea to make a prediction where you state what products will be formed at each electrode. Copper chloride solution contains positively charged copper and hydrogen ions and negatively charged chloride and hydroxide ions. If the metal ion is less reactive than hydrogen, the metal will be discharged at the cathode, otherwise hydrogen ions will be. If halogen ion is present, then it will be discharged at the anode. Otherwise, hydroxide ions will be discharged to form oxygen gas. Can you predict what products will be formed from the electrolysis of copper chloride?
When you are ready to test your prediction, 5 volts is selected on the power pack, and then the power pack is switched on. You need to observe the electrodes carefully in order to work out what product is forming at each electrode. Are either of the electrodes changing colour? This could indicate that a metal is forming on the electrode. Are there bubbles of gas forming? The gas formed will either be chlorine, oxygen, or hydrogen. To test to see if chlorine is formed, use tweezers to hold a piece of damp blue litmus paper just above the bubbling electrode. If the litmus paper turns white, this is a positive test for chlorine, because chlorine bleaches the paper.
Only leave the electrolysis running for 5 minutes. This short time, plus a low voltage, will ensure that if toxic chlorine gas is produced, it will only be in a small amount, so will not present a risk. This does mean that you will not be able to collect enough gas to test for oxygen or hydrogen, though. To test for these, you need to fill a test tube with the gas. Adding a glowing splint into oxygen will cause it to reignite. Adding a lighted splint into hydrogen will cause a squeaky pop noise. However, you can still work out which gas was made. If the gas was formed at the anode and did not bleach the litmus paper, then it is oxygen. If the gas is produced at the cathode, then it is hydrogen.
For copper chloride solution, you will observe that the cathode goes a brown colour. This is because copper has been deposited on it. This covering of a metal over electrode is called electroplating. Bubbles of chlorine gas were formed at the anode.
Record your observations and what elements are formed in a results table, and repeat this procedure for some other ionic compounds. Examples you can use are copper 2 sulfate, sodium chloride, and sodium sulfate.